Welcome to the third and final part of Module 7 on genomic selection, where we're discussing the genomic selection schemes that can be used in plant breeding. We have already talked about what I called Scheme A1 and Scheme A2, and now I'm going to talk about Scheme A3. And this is basically the same as Scheme A1, but now we're going to throw some rapid cycling genomic selection alongside of it. As before, the germplasm in your current phenotyping program is used as your training population. And as I've outlined this scheme A3, the selection population now is a population of F2 individuals derived from crosses amongst the best lines in your training population. The scheme is, the rationale is really about the same as in scheme A1, but the major limitation to plant breeding is the limitation your gain per year is the amount of time it takes to go through a cycle of phenotypic selection. So most of the cycle of phenotypic selection is actually spent increasing seed for phenotyping and then phenotyping multiple years in locations. And this phenotyping is also expensive. These results in low gains per year and low gains per dollar spent. So scheme A3 is meant to try to address those. So here is scheme A3. Scheme is built on scheme A1, which is everything I'm highlighting here. Steps 1, 2, and 3 are the same as in scheme A1 and same as they are in scheme A2. The only difference is you now take the best lines that you have phenotyped and genotyped and used to build your model. You cross the best lines and self them best lines and get F1s. The F1s are then self to get F2s, and now you basically enter rapid cycling genomic selection that we described before. You genotype the F2s, predict the value of each one, may use marker-assisted selection on. Cross the best F2s to get F1s, and those F1s enter the next cycle, and it just keeps repeating itself. Now, at the end of every cycle of rapid cycling genomic selection, you can take the best lines and feed them into phenotyping in your field program. So, really nothing new here. Scheme A1 is on the left, rapid cycling is on the right, and they fit together quite well. Some advantages of scheme A3. Well, same advantages really we listed for scheme A's 1 and 2. But scheme A3 also minimizes the duration of a breeding cycle. It increases your gain per year when GS accuracy is high. It also generates F2 derived families for field testing, and you can go in them and do some pedigree selection as well. And these F2-3s really are still segregating and be used in participatory plant breeding. And of course, other variations of the rapid cycling can be added in to that component of scheme A3. Now, these three schemes are certainly not exclusive. Here you have scheme 1. You can, of course, easily add on scheme 2 on top of it. Scheme A1 is actually a constant. You do that every year anyways. And so you're always going to be doing that. And from scheme A1, you can also add on scheme A3. And from each of these, you're generating advanced lines with predicted to have good values, and they all can enter in your next stages of next season's field testing. So again, they're not exclusive. They're actually combined together quite well, and you can do whichever one you want, or do 2 of the 3, or all 3. Depends on how your comfort level and your resources. So the summary of schemes A1, 2, and 3. They can all increase your accuracy of field selection. A2 and 3 can greatly expand the size of a testing program at early stages. Schemes A1, 2, and 3 all build upon existing breeding programs and populations, and they all can be used simultaneously. In each one of them, the data accumulates over years, and that can help you build more robust prediction models, and they facilitate collaboration between breeders. It can also enable a more efficient use of testing plans and increase your gain per year, GS accuracy, the probability of identifying a new variety. All the things we want to do, they can help you do. There are some disadvantages of schemes A1, 2, and 3. The line tested in stages 1 and 4, and the lines maybe that you're throwing in there from your cooperative germplasm tests and commercial variety tests, they may lack diversity for some traits you wish to improve. If so, then you must develop an additional introgression plan to get useful genes for those traits into your populations. And if your stage 1, 2, 3, and 4 tests are really quite small, then predictions may not be good. Basically, your training population may be too small if those stages of testing are not large enough. Adding in those cooperative germplasm tests and commercial variety tests can help, but they can also be disadvantageous if they are not highly related to your germplasm. In other words, if lines in stage 1, 2, and 3 for testing from your program are not highly related to these other cooperative tests, then these cooperative tests may not really contribute greatly to prediction accuracies. The genotyping of F2 plants in scheme A3 can be difficult for determining heterozygotes, etc. And so you can go back to the section on rapid cycling and get some considerations there of what material to use. And certainly scheme A3 is more difficult to execute than schemes A1 and 2. I just want to elaborate a little bit on this concept of sharing information and predictions in germplasm between programs. Let's say there's two breeding programs. Breeder A's program, which has stage 1, 2, and 3 of testing, and they all are all conducted in Breeder A's environments. And then you have Breeder B's program. Let's say both of these programs genotype their lines with the same markers. Then what you can do is use data from program A to develop a genomic selection model. This model then can be used to predict the value of Breeder B's lines in Breeder A's environments. So now Breeder A can access germplasm from program B, predict its value in Breeder A's environments, and basically increase the size of their program by accessing germplasm from B, predicting its value to environments relevant to A, and asking for some of that germplasm. Same can be done for B. You take data from Breeder B and you develop a genomic selection model, and you can use this model to predict the value of Breeder A lines in Breeder B's environment. And again, basically greatly increasing the effective size of each program by accessing and leveraging data from each other. The benefits to these schemes A1, 2, and 3 to a breeding program is, first of all, you can implement this immediately. If you're already doing phenotyping, doing stage 1, 2, 3, and 4 testing, doing these cooperative trials, you're already doing the phenotyping. Layer on the genetic information and get some benefits from it. It can be implemented in populations that are the most relevant to your breeding goals and developing varieties for your environments. Improves the value of predictive lines, particularly with lines that are only experiencing limited phenotyping. Your data accumulates year after year to improve your prediction abilities, and you can connect your program to other programs who are doing the same genotyping, using the same genotyping platform. And these schemes all complement and supplement rapid cycling genomic selection. And you can also use these programs to diversify your germplasm each year. And you can use this same data to do association analysis and search for useful QTLs in your most relevant genetic backgrounds. Here is a quiz for the last two sections of Module 7. And you can take this quiz if you wish. And if you want, I will look over your answers and let you know how you did. Thank you for viewing the material. And if you have any questions, please feel free to contact me.